The angle bisector of the acute angle formed at the origin by the graphs of the lines y equals x and y equals 3x has equation y equals kx. What is k? So here's the graph on the coordinate plane, right? We have the two lines starting at the origin. So we have origin labeled as 0, 0. Let us draw a horizontal line, y equals 3. And let's draw the equation y equals kx, such that it is the angle bisector of this angle formed here. So this is y equals kx. Let's see what other points we can notice on this graph. First off, the intersection of y equals 3x and y equals x with y equals 3 are respectively 1, 3 and 3, 3. We also notice that by angle bisector theorem, the length of this side over the length of this is equal to the length of this side over the length of this. We know that overall the distance between the intersection points is a length of 2. So let's redraw our diagram and see what we can notice from here. We have our sides of the triangle. Let's look at if we can find the lengths of the sides. So first we have this distance is already 2, right? We currently have the coordinates of this is 1, 3, and this is 0, 0, and 3, 3. To find this leg, all we need to do is apply the Pythagorean theorem, right? Distance formula for 0, 0 to 1, 3 is the square root of 1 squared plus 3 squared, which is the square root of 10. And then for this line segment here, we have from 0, 0 to 3, 3. Well, that's just a 45, 45, 90 right triangle. Applying Pythag again gives us 3 root 2. So we have all these lengths. Now we draw our angle bisector. And we realize that we have a ratio. Let us first set each of these segments respectively. So we know that the coordinate of this point on the graph is going to be some value x, y. So if the x coordinate is a distance x from the y-axis, then let us set this length here to be x minus 1, because there is a distance of 1 that is not considered. And then we know that the other part of the segment will just be 2 minus x minus 1, which is 3 minus x. And that gives us our other segment. Okay, now applying angle bisector theorem, we have root 10 over x minus 1 equals 3 root 2 over 3 minus x. Cross multiplying gives us 3 root 10 minus root 10x equals 3 root 2 times x minus 3 root 2. We combine the constant terms on one side and the variable terms on the other to give us 3 root 10 plus 3 root 2 equals 3 root 2 plus 10 root 10 times x. And then we can divide the left-hand side by the right-hand side. That gives us 3 root 10 plus 3 root 2 over 3 root 2 plus root 10 equals x. Okay. We currently notice that there is a root 2 term on every term in this division. So taking that out gives us 3 root 5 plus 3 over 3 plus root 5. Let's do a multiplication by conjugates. 3 minus root 5, 3 minus root 5. We end up with 6 root 5 minus 6 over 4. And simplifying gives us 3 root 5 minus 3 over 2. So now we have the x coordinate and the y coordinate. Let's write out what those are. X comma y equals 3 root 5 minus 3 over 2, comma 3. Okay, and then we want to find the slope of this line. So since we know this line has 0.00 and 0.3 root 5 minus 3 over 2, comma 3, then all we need to do is find the slope of the line. Well, the slope will just be 3 minus 0 over 3 root 5 minus 3 over 2 minus 0. Doing some calculations on that gives us 3 times 2 over 3 root 5 minus 3. Canceling out and multiply by the conjugate, we get a final answer of root 5 plus 1 over 2, or just 1 plus root 5 over 2, and that is our answer choice A.